Okay. Areas of polygons. So we're going to cover a couple areas here. We have talked about area of a rectangle and area of a triangle. So area of a rectangle is base times height. That's going to be important next chapter. And then area of a triangle is base times height divided by 2. That'll also be important in like this next part of the chapter. But here's a couple area formulas that you probably don't know. Before we get to that formula, let's just review what makes something a rhombus and what makes something a kite. So what makes a rhombus? I know it has 4 sides, but what makes a rhombus, specifically a rhombus? And there's a picture of it down in the bottom on the left side. But what makes a rhombus more specific than like a parallelogram? Okay.
The rhombuses have equal sides.
Exactly right. The rhombus has 4 equal sides. Thank you. That took first hour entirely too long. Rhombus has 4 equal sides. It does not have 4 right angles. That would make it a square. Just has 4 equal sides. And then a kite, I'll go ahead and help you with this one just because it's hard to put it into words sometimes. But a kite has 2 pairs of sides that are the same. But instead of like a parallelogram where it's the opposite sides, it's the sides right next to each other. So it almost looks like a diamond, but like a diamond that doesn't have 4 sides that are equal. But 2 sides that are equal that are right next to each other. The formula for finding the area of both of those, I really genuinely don't know why they stick this little portion into this section, but they do, because it doesn't really have anything to do with the rest of the section. But the formula for finding the area of those shapes is going to be diagonal 1 times diagonal 2 divided by 2. So D in this case is not diameter because it's not a circle. It's a diagonal. Now a diagonal, so you'll want to write that in the little thing at the top that says area of rhombus and kite. A diagonal, by definition, is the distance from one vertex to another vertex that's not next to it. Well, when you only have a 4-sided figure, the diagonals are a little bit easier to identify because it's the lines that go across the figure. You'll see right here the way that they write it in the book is 1/2 diagonal 1 times diagonal 2. So you could also write it like this if you wanted to, like if this makes more sense to you. But for whatever reason, people, I don't know, 1/2s always throw us off. So there's another way of writing that right here, 1/2 diagonal 1 times diagonal 2, or like 0.5 times diagonal 1 diagonal 2. So a lot of times you're going to see it labeled on the outside, just an FYI, but I want to prepare you for your homework. There's a chance that they might label it in here, like 4 and 4. Okay, if they did that on your homework, how long would the entire diagonal be? 8. Okay, just be prepared for that on your homework. So a couple of really straightforward examples here. The first one diagonal is 6, and the other diagonal is 8. So when we take the area, multiply the diagonals and cut it in half, and we get 24. 8 times 6 is 48, and then half of 48 is 24, and this is area, so it'll be units squared. Okay. So go ahead and quickly do the second one on your own. Pretty straightforward. Multiply the diagonals, cut it in half. Does anybody still need a calculator? And what do we get? 35. Thanks, Jake. So 7 times 10 is 70, and then cut in half is 35. Very good. Now, for the sake of time, I'm going to skip the next 2 problems on your note sheet. It's all I would be doing is taking the 2 numbers and multiplying them and cutting it in half. I think we're okay there. But if you have your worksheet in front of you, I just want to give you a heads up. And if you don't, that's okay. But I want to give you a heads up that number 4 on your worksheet. Number 4, they don't give you one of the diagonals. They give you like this number and this number. So you might have to do a little bit of Pythagorean theorem. Actually, they give you, I guess, this number right here. But just keep in mind that on your homework on number 4, and you could like make yourself a note on your note sheet if you wanted to. Number 4, you're probably going to have to do a little bit of Pythagorean theorem first, just so you know. Okay? Are we okay with me skipping those 2 problems? All right, pretty straightforward, I think. Okay, let's get into the new stuff for today. We're going to go over area of a regular polygon. So any regular polygon, whether it's a regular quadrilateral, regular pentagon, regular hexagon, regular octagon, regular heptagon, whatever. Let's review what regular means. Does anybody remember what regular means? If I talk about a regular polygon, what does regular mean? Okay, let me draw a couple regular polygons up here. This equilateral triangle would be a regular polygon, and this square would be a regular polygon.
Equals and equal size.
Perfect. Good. Okay, so you don't need to write that down necessarily, but if you don't know what regular means, then it might benefit you to write it down. But regular just means equal angles and equal sides. So equilateral triangles, for example, squares, pentagons, where all of these sides and angles are the same, hexagons, where all of the sides and angles are the same, like a stop sign. Let's go over some vocab with that, and I will tell you what I want you to write on your blue sheet and what I don't think is that important. Like center, probably not that important. If I told you to find the center of a polygon, I think you would know exactly what I'm talking about. It's the point in the middle. Center, middle are synonyms. So technically, it's the center of the circumscribed circle, because we don't talk about polygons having a center point normally. But you could put a circle around it, and then that's how they get by with that. But just so you guys know, the center of a polygon is in the middle. The radius of a polygon. I don't want you to write this definition down, but I do want you to write something down here. So a radius goes from the center to a vertex. Okay? So you can either write that somewhere around the blue area here in the middle, or you could write, I don't know, find a place to write that. But you should know what a radius of a polygon is, because it's not quite like a radius of a circle. A radius of a circle just goes from the center to a point on the circle. A radius of a polygon specifically goes from the center to a vertex, because if we put a circle around it, that's where the points would be on the circle, at the vertex. So circles had an unlimited amount of radii. Polygons don't. However many vertices your polygon has is how many radii it would have. So like a square would have 4 radii. Here, 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 and here. A triangle would have 3 radii. Here, here, and here. So anytime you're going from the center to a vertex, that would be a radius. Here's your new word that I also want you to write down, but I'll tell you what I want you to write down, is an apothem, okay? I want you to write down everything that's not in parentheses. So don't worry about writing the parentheses stuff down. But you should, probably underlining the wrong thing. You should write this down. It goes from the center to any side of the polygon. That's a brand new word for you, kind of a funky word, but the apothem goes from the center straight to the side of the polygon. And there's a couple properties with that I want you to add to your little picture that's there.
So would the apothem be like the radius kind of?
It's like it, but it's not in the same spot. So if you guys look at the difference, the radius goes from the center to a vertex. The apothem is shorter, and it goes from the center to the middle of the side. Okay? Now, I just said that. It goes to the middle of the side, so if you want to add some markings in here, an apothem always cuts a side in half. Always. And it is always perpendicular. Okay, so if I drew another one in here, it would have to be perpendicular to the side, and it has to cut that side in half. So it always goes directly to the middle of the side. And again, if there are 6 sides on a figure, it would have 6 apothems. So in general, however many sides it has, that's how many radii it has, and that's how many apothems it has. So if you have a hexagon with 6 sides, it would have 6 radii to each corner point, and it would have 6 apothems to each side. The last little thing we're going to talk about here, we don't need to write the definition down because we just did this in the last chapter, but the central angle. So remember, central angles are angles whose vertices are at the center. Pretty straightforward. Now again, if something has 6 sides, it would have 6 different central angles. So if I go back to my triangle and my square example, that looks kind of like a rectangle at the moment. Your central angle is where the 2 radii make an angle. So this triangle would have 1 central angle, 2 central angles, 3 central angles. A square would have 1, 2, 3, 4. A pentagon, which I'm not even going to try and draw, a pentagon would have 5 central angles. So essentially, it's just like slices of a pizza again, except it's a polygon instead of a circle. Okay, let's talk real quick about how we find the central angle. So this note sheet wasn't structured very well, but there is a box that says how to find a central angle. You guys see it in the middle? It's the second box. What's a full circle? How many degrees? 360. So what we do here to find the measure of a central angle for a regular polygon is take a full circle 360 and we divide it by the number of sides it has. Okay, so if it has 4 sides, we take 360 divided by 4. If it has 10 sides, we take 360 divided by 10. Pretty straightforward. Again, think of like a pizza. If I had a full pizza and I had to feed 12 people, I would take the pizza and divide it into 12 slices. And so the more sides a shape has, the smaller that angle would get. So this will be quick. They want us to find the central angle of a regular hexagon. So that's kind of like the picture that we just looked at. It's like us saying, what's this measure right here? Okay? To find that measure, we'll take 360 divided by the number of sides, which is 6 for a hexagon. So what's 360 divided by 6? 60 degrees, okay? That's how big every single central angle is in the hexagon. So let me go back again and put that in terms of the picture that you're looking at. Okay, I'll go back to the slide. But here's a hexagon right here. Here's a regular hexagon. So what that means is this angle is 60 degrees. So is this angle. So is this angle. And that angle. And that angle. So every single angle that kind of, oh, and this one. Every single angle that stems from the center, right in the middle, all have to be 60 degrees. Pentagons have how many sides? Very good, guys. 5. That's always a hard one to remember. There's no good way to remember that one. 360 divided by 5 is? 72. Okay, 30 sides. So again, the more sides it has, the smaller that angle is going to get, because the smaller your little slices of the pie would be. So if it has 30 sides, that central angle is probably going to be pretty small, which is okay. 360 divided by 30 is what? 12 degrees. And then our last one, 360 divided by 16, and that's going to give us a decimal, which is okay. You can have a decimal. It doesn't even have to be a terminating decimal. It can be a repeating decimal. It can be an irrational decimal. What's 360 divided by 16? 22.5. Thank you. Okay, and that's going to be helpful in a little bit. We have to start solving a little bit of trigonometry stuff. So because they come back into our lives just for a brief moment today. Okay. So on this problem right here, it says in diagram, ABCDE is a regular pentagon inscribed in circle F. That's not terribly important. Find each angle measure. The first one they want us to find is AFB. This angle right here is the central angle. Okay, that's one example of a central angle. So if they want us to find that, we'll take 360 divided by, it's a pentagon, so it has 5 sides, and we already did that on the last problem. It was 72 degrees. One thing we learned earlier. Well, we did something very similar to this earlier on in the year. So I don't know if that answered your question, but that's how you find a central angle. Now, AFG, this is a good one to go over too, because we're going to have to do this in a little bit. AFG. Everyone try and spot AFG on your own, because when you read angles, you have to read them on your own. AFG is this angle right here, okay? That angle F to G is the apothem, and the apothem cuts the central angle in half. So if you are thinking to yourself, oh, well, if the full central angle is 72, I'll just cut it in half, that you're exactly right. So if the full central angle is 72, this blue one is going to be half of that, half of the central angle. What's half of 72? 36 degrees. So your little apothem, that segment that's perpendicular to the side, it's like it's taking that triangle and cutting it directly in half. And then the last one they say is to find GAF. Okay, this angle right here, GAF. Well, we have a triangle here. What do triangles have to add up to? 180. That degree is 90. This degree is 36 degrees. So take 90 and 36, take it away from, it's just so small, I'm so sorry. But you're basically looking at a triangle. If I zoomed in on it, that looks like this. And I want to know the third angle. So take 90 and 36 away from 180, and what do we get? 54 degrees. And if that's 54, then the other corner would also be 54, just to kind of put that into perspective.
Wait, actually, okay. Wait.
This angle, this little guy was 36, that one's 90, and that's a little triangle, so I took 180 minus 90 and 36. Question?
How do you understand why 8.72 divided by 2?
Okay, so here, this red one, that's the full central angle. Did you understand how I got that measured?
Yeah.
Okay. So if all of that's 72, this apothem right here, FG, cuts it in half. So if the full red angle is 72, then the blue one, AFG, is only half of that. Great questions, really. Because we can't move forward if we got stuck on a part in the back. So, anything else? Okay. We're actually going to skip these questions right here because it's essentially what we just did. But let's go over, because you'll have some problems on your homework where you have to identify like a center, a radius, a apothem. And yours is a little bit more organized than mine is. Let's start with the center. That's probably going to be pretty easy for you. Who can raise their hand and tell me what the center point of this square would be? Holly? P. Point P. Good. Okay. Radius. Center's pretty straightforward. Radius goes from the center to a vertex. There are 4 different vertices on a square. 4 different. Nope, just one of them. So who can raise their hand and name one radius? They drew in 2 of them, but who can raise their hand and name one? Jake? That's the apothem. Try again. It goes from the center. No, put your hands down. He's going to finish it. It goes from the center to a vertex, like a corner point. That will work. Or PX, whatever. Order doesn't really matter. PY was another example. Okay. We already got the answer for apothem. The apothem is PQ. Okay. Do we see the difference? The radius is always longer on a problem like this. The radius goes to each vertex. The apothem is the shorter one that goes to the middle of the side. And then the last one they want us to name is the central angle. Okay, the central angle is made up of those 2 radii. You want to give it a shot, Jace? You're close. XPY. The central angle is the full angle in the center. So he said XPQ at first. That would be half the central angle. And we're going to skip that, but if we wanted to find the measure of the central angle XPY, we would just take 360 divided by 4, and then we'd get 90 degrees, so on and so forth. Okay. Are we okay with the vocabulary part of it? Before we get into the fun stuff.
I think so.
Okay. Finding area of a regular polygon. What this slide is walking you through, we're not going to go through it here too in depth, but it's basically telling you where this formula comes from. Okay, they didn't finish off this picture of the hexagon, which is also very difficult for me. Okay, hexagon, whatever. The formula comes from the fact that you can split any regular polygon. This might be a better visual. You can split it into a bunch of different triangles that are all the same size. So what they're doing here is they're taking the area of one of those little triangles and they're multiplying it by the number of sides. So they're taking the area of this triangle right here and they're multiplying it by 6 sides, okay? What that eventually, through all of this business, leads to, because if you think about triangles being base times height divided by 2, what that eventually leads to is this formula here. 1/2 Apophthegm times perimeter. Now, because we, again, tend to not like fractions very much, I'm going to write it just a little bit different. So you actually need to go back to the front of your sheet. I'm so sorry. No, it's not organized very well here. And you see this top box where it says formula for area of a regular polygon? That's what we're going to write this. Okay? Your formula is Apophthegm times perimeter divided by 2. So there's a big A and there's a little a. Big A stands for area. Little a stands for Apophthegm. Now, going into surface area formulas next in the rest of the chapter and volume, you're going to want to label like what the variables all stand for. Because like Apophthegm was a new, like you probably knew what P, like you probably could have figured out what P stood for, but A was a new one for us, Apophthegm was new. And when we get into volume stuff and surface area stuff, we'll have some new variables as well, like slant height, that'll be a new one for you. Okay, the other way of writing that, if you'd rather write it this way, you certainly can, the 1/2 Apophthegm times perimeter, or 0.5 times Apophthegm times perimeter. So it's kind of personal preference. Some people just like multiplying by 0.5, and some people, they don't like decimals, so they want to divide by 2. That picture here looks like a crunch wrap from Taco Bell. Geometry. What? My oldest brother made a homemade crunch wrap last night for dinner. Huh? I haven't had Taco Bell since I had food poisoning over finals week in December. Haven't had it. I'll never eat again. I just won't eat the meat. Like, I'll eat, like, your tortillas. I will not eat your meat ever again. That was, like, the worst food poisoning I've ever had. I would never do it again. Remember when I had to leave school? I don't know if that was the day I had you guys. During finals week back in December, I had to leave school in the morning because I had such bad food poisoning. It's like, and so I came here and I was like lightheaded and I was like, I can't make it. Okay, we gotta keep going. We're out of time. So these two examples, guys, are gonna be the most straightforward examples of this area formula, and then we'll go a little bit more in depth from there. So these two formulas, your formula for area is Apophthegm times perimeter divided by 2. So you have to have those two things. You have to have yeah, we're flipped over on the back again. You gotta have the Apophthegm and you gotta have the perimeter. Okay? In this problem, your Apophthegm is given. Your Apophthegm goes from the center to the middle of a side, which is 8. Perimeter. Who has a thought for how I could find the perimeter of that triangle? Oh, this table has answered all of the questions, although I really appreciate it, 3 of you. Add up all the sides, okay? And they're all the same. So if this is 27.7, this is 27.7, and the bottom is also 27.7. So you can add it 3 times, or take 27.7 times what? 3. Okay, what's 27.7 times 3? 82.1. Okay, and once you have those two pieces, then you just plug them into the formula and it's not so bad. So area equals Apophthegm times perimeter divided by 2. So go ahead and type that in, because I don't have a calculator. Apophthegm times perimeter divided by 2. Let's go. I haven't heard from Zach today. Zach, what do we get when we type that in? And there's no units here, so I'm just going to put units squared. And is it exactly 332.4? Okay, so I probably should have put an equal sign there. Nitpicky things, but they matter. Okay, so letter B, for the sake of time, we're gonna go through it really quick. But same kind of thing. Let's go. I haven't heard much from Tanner today. What's the opossum, Tanner, in the second one? 19.2. And the side length is 14, and there are 4, 5, 6, 7, 8, 9 sides. So let's go, Sam, what's 14 times 9? Sorry, Luke.
126.
And then we'll type it in, opossum times perimeter divided by 2. So it's not just opossum times the side length, right? You can't just take 19.2 times 14, which you can believe I see every single year happen. You have to find the perimeter. That'll be the same when we start getting into surface area stuff, so that'll be important. Let's go, Andrew. Let me know what you get when you type in 19.2 times 126 divided by 2. That seems big to me. Is that what you guys getting? Okay, say it again, sorry. 1,000. Okay. 1,200.6. Like that? Okay. Units squared. Good. Alright, that just seemed big to me. Okay. Questions so far? Now, what happens, as we'll see in a second, when you either don't have the opossum or you don't have a side length to find the perimeter with? Let's look. Number five, we do have the opossum. Which side length up there is the opossum? Who can raise their hand and tell me? Luke? Say it out loud.
8.
You read the first time.
That's it, told me.
No, it is not.
6.5. You gotta be confident with your answers, so don't fall to the pressures of peer pressure. The opossum is 6.5. 8 is the radius, which we don't use in the problem. Okay? But you can't find perimeter here because you don't know any of the side lengths. So what we can do, since I have a lovely little right triangle here, I can find this little piece right here using Pythagorean theorem. Is exactly right.
What? You are so smart, man.
No, check your mouth. This is how you make me mad. 6.5 squared plus x squared equals 8 squared. I gotta go through this quickly. 6.5 squared. Okay, stop acting like idiots, right? That's our goal for the rest of the semester. Just to not act up. 42.25. 8 squared is 64. Minus the 42.25. And you get 21.75. And this is going to be an approximated answer. That's a 21. It looks funky. 21.75. And then square roots. Don't divide by 2, but we should square roots for sure. And we get about 4.7 when we round. Okay. Now, you need to put that in perspective of what you just found. What you just found was this right here. So I'm going to erase that x and put a 4.7. Okay? I need the perimeter eventually. That's going to help me. Now, if that's 4.7, who has an idea of how I could find the entire side? Let's go, Jace. Times it by 2, which is 9.4. Now, 9.4 is not the perimeter. 9.4 is one side length. So now how do I find the perimeter, Seth?
4. 5.
5 sides. 9.4 times 5, which is what?
47.
Okay, and now I can do opossum times perimeter divided by 2. Now I'm good. So area equals opossum times perimeter divided by 2. 6.5 times 47 divided by 2 is 152.75. Now that is units squared after that point. Okay. The last kind of scenario we're going to go over right now is what happens if they only give you a side length. Let's get the perimeter out of the way because the perimeter we can for sure find. Each side is 7, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So what's 7 times 10? Okay, that's your perimeter. So let's just leave that up in the top right corner because we know that that's not going to change. I don't have the apothem here, so here's what I'm going to do. I'm going to draw in my own little right triangle right here. I'm going to draw in the center. Here's the apothem. That's what I'm going to look for, so I'm going to label it X right now. And then draw in my own little right triangle. Super tiny little sliver of a right triangle. If the entire side is 7, how can I find just this piece right here? Cut it in half, someone was just saying. So half of 7 is 3.5. Okay. That's not your apothem, but it's half the side length. Okay. Can you do Pythagorean theorem on this right triangle? No, because you don't know the hypotenuse, right? You don't know the radius. So instead of Pythagorean theorem, we're going to use SOHCAHTOA. And here's how we're going to do that. Bear with me here for a second. I know I'm going to get cut off. I just know it right now. We need to find this angle right there. Okay, this little angle, sliver of an angle right there. That angle is half the central angle. So if we can find the central angle and then cut it in half, I will know that angle measure. How do you find the central angle again? 360 divided by the number of sides. There's 10 sides. So what's 360 divided by 10? Okay, that's an entire central angle. So if I were to put that into perspective, that's this angle right here. And I only need half of it. So what's half of 36? 18. That's the angle measure we're going to use for our SOHCAHTOA. Half the central angle. So if you need to make yourself a note, find the central angle, cut it in half. Or find half the central angle. 360 divided by the number of sides, cut in half. Okay, and then from that, if we look at our SOHCAHTOA, I'm going to get cut off any second here. You got to think what 2 pieces you have. You have opposite, adjacent, hypotenuse, and this will be on your final exam, so we got to make sure that we understand how to do this. You have opposite and adjacent. We don't have the hypotenuse here. That would be this length over here, which we don't know. Tangent uses opposite and adjacent. So we're going to set up the tangent of 18 degrees, which came from half the central angle, equals opposite over adjacent 3.5 over x. And that's how we're going to solve for the apothem. Tangent of 18 is 0.3249. I know it's been a while since you've seen this, but this will 100% be on your final exam pretty heavily.
Good morning, Team 14. Can I please have you stand to give the Pledge of Allegiance? I
Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you. And now for the Titan Student Bulletin.
Okay, keep writing what I write down, please, quietly. Don't talk.
Spring Sport Seniors. We will do the senior picture for spring sport athletes this Wednesday morning, May 3rd at 7:45 in the main gym. Be on time, they will not wait. 9th graders, on Wednesday, May 3rd, you will be doing health screening. If you wear contacts and or glasses, please be sure to wear them and bring them that day. Final exam. The final exam schedule is posted on our website. It is listed on the left side under important links. Play-production class auditions. Are you interested in being part of an elite group? Auditions for the play-production class will be held May 4th. Auditions are open to 2017-2018 juniors and seniors. Theater class are not required. Please see Mr. Nieghauser in room A11 for an audition packet. And now,
Write that down if you didn't.
Soccer.
Hey, what's up, guys? Hey, Wood. Hey, Jaden Torgerson. And tonight you're playing La Vista South Varsity Boys. Host Lincoln Northeast in the first round of districts. We play tonight at 5, so make sure to come out, be loud, and hope to see y'all there. And then just the winner of tonight's game will play tomorrow at 6 against either Papio or Omaha South in the district championship.
Thank you, guys. That's all for today, folks, and have a wonderful National Loyalty Day.
Okay, so after all that trigonometry, yes, question.
Is 18, is that like the full angle up there? Is that like a cut in half?
It's the central angle cut in half. So like the full central angle was 36 degrees, because that would be 360 divided by 10 sides. And then the 18 was half of that. Okay, that's your apothem. So then to finish that off, we'll do apothem times perimeter divided by 2. So my area formula, apothem, which was 10.8, approximately, I'm totally rounding, times the perimeter, which was 70, divided by 2. 10.8 times 70 divided by 2 is about 3, it's exactly, but since I rounded it earlier, 378 units squared. Okay, so what I told First Hour is you for sure need to do 1 through 12 on your worksheet, and those of you that, you know, if this class is easy for you, then you should challenge yourself to do 13 and 14 on your own and see if you can do them. Which there are many people in here that I think you can take that challenge upon yourself. But for sure on your homework, we're going to skip the last one. For sure on your homework, you need to do 1 through 12. Those are very straightforward problems. Number 4, you have to do a little bit of Pythagorean theorem. Okay? You do have like 2 minutes if you wanted to get started. I know it's not much time, but you could make use of those 2 minutes. Test